Part 1. What is blockchain? Hey everyone! Today we're going to explore one of the most fascinating and groundbreaking technologies of the digital age, blockchain. It might sound intimidating or overly technical, but once you understand it, you'll see it's actually simple and incredibly useful. Let's start with a real-life example. Imagine your whole village shares one big ledger. Every time someone buys or sells something, it gets recorded in this ledger. Here's the twist. Everyone has their own copy of the ledger. If someone tries to cheat, erase, or change a transaction, they'll be caught immediately because all the other copies still hold the original data. That's basically how blockchain works. According to Investopedia, blockchain is a distributed database where information is stored in blocks, and those blocks are linked together to form a chain. Each block contains transaction data, a timestamp, a hash. Think of it like the block's fingerprint. The biggest difference between blockchain and a traditional database is that there's no central server. Instead, blockchain exists on a network of thousands of computers, called nodes, all over the world. Each computer keeps a copy of the data and verifies every change together. Thanks to this setup, blockchain is virtually impossible to hack or alter once information has been recorded. This technology was first introduced in 2008 by a mysterious individual or group known as Satoshi Nakamoto. It was first applied to Bitcoin, the most famous cryptocurrency, but since then, blockchain has evolved far beyond just crypto, finding applications in healthcare, education, finance, and even environmental protection. Part 2. How does blockchain work? To understand how blockchain operates, let's walk through the steps of a transaction. Step 1. Creating a transaction. Let's say you want to send 1 Bitcoin to Jack. You enter Jack's wallet address, the amount, and confirm the transaction. Step 2. Broadcasting to the network. Your transaction information is sent to thousands of computers, nodes, around the world. This is the blockchain network. Step 3. Verification nodes will check if you have enough balance, if your digital signature is valid, if the transaction is not a duplicate. If everything checks out, the transaction is marked as approved. Step 4. Bundling into a block. Hundreds or thousands of approved transactions are grouped together into a new block. Step 5. Consensus mechanism. Before the block can be added to the chain, nodes must agree it's valid. This is called consensus. Common methods include proof of work, POW. Computers solve a complex puzzle. The first to solve it adds the block and gets a reward. Bitcoin uses this. Proof of stake, POS. Those holding more coins have a higher chance to validate transactions and add blocks. Ethereum uses this after its upgrade. Step 6. Adding the block. Once approved, the block is linked to the end of the blockchain. Each block contains the hash of the previous one. So altering a block would require changing all subsequent blocks. Nearly impossible. Step 7. Updating the entire network. All nodes receive the latest blockchain copy, keeping everything synchronized. Simple analogy. Think of blockchain like an online diary where each new page is written only if everyone agrees it's correct. Once the page is published and shared, no one can tear it out. Hash, the security wall. A hash is a unique string generated from a block's content. Even changing a single dot in the block will completely alter the hash, instantly exposing any tampering. Part 3. Types of blockchain. There are 4 main types. Public blockchain, open to anyone. Examples: Bitcoin, Ethereum Pros, transparent. Decentralized cons. Slower speed, high fees during congestion. Private blockchain, restricted, only authorized participants can join. Example: a bank's internal system. Pros, fast, controlled environment. Cons, less decentralized consortium blockchain managed by multiple organizations. Example, a group of shipping companies tracking containers, hybrid blockchain. A, mix of public and private. Example, a company makes product data public for customers, but keeps internal records, private. Part 4. Real-world applications blockchain isn't just for cryptocurrencies. Key uses include cryptocurrencies, Bitcoin, Ethereum smart contracts, automatically execute when conditions are met, e.g., insurance payout triggered by weather data, DeFi, financial transactions without banks, supply chain, Walmart. Uses it to track food from farm to store copyright protection. Musicians record songs on blockchain for transparent royalties, healthcare, secure medical records, storage, e-government. Estonia uses blockchain for citizen data management. Part 5. Pros and cons. Pros. Transparency, security. No intermediaries needed. Extremely hard to forge data. Cons. High energy use, POW. Lack of clear legal framework, scalability challenges. Can be complex for beginners. Part 6. The future of blockchain. Merging trends include Web3, giving users control over their own data. NFT 2.0, tokenizing real-world assets. Green blockchain, reducing energy consumption. Part 7. Conclusion. Blockchain isn't just the backbone of Bitcoin, it's a major leap forward in how we store and share information. Like all new tech, it needs time to mature and achieve widespread adoption. If you find this topic fascinating, keep exploring and experimenting, because blockchain could become a key part of our future. Thanks for watching, and see you in the next one.